check. Is there audio there, Rob? You see audio on the...
Yeah, I see audio. You want to put it on his...
Well, Tina's going to use it first.
Okay. Can we just check the audio at that level rather than that level? Just need to hold it up there. Yeah.
Hello?
No,
Hello?
no, just check straight.
Yeah. How's it doing? Levels okay?
Good. Thank
Awesome.
you. Oh, I think we got... You get some sound.
We're good to go, yeah.
Great.
No. Do you want to just keep an eye? Just keep that mic on. Or keep the camera on.
Yeah.
We'll have to steal his lapel mic there. Hand it back to her. Oh yeah, I'll pan over to you.
Hello. Welcome to the...
Oh, you don't...
No? Not this one?
You'll have to yell to the room. Oh, there you go.
Both mics? Whoa, there we go. Hello again, and welcome to the October 2018 Quality Talk. I'd just like to start off by saying I'm super impressed that we're starting at 12:02, given the last-minute room change and logistics stuff going on here. So thank you all for your cooperation, and sorry for the last-minute confusion. So welcome back. This is our first quality talk since before the summer and targeting quality break. And about targeting quality, I see a lot of faces here today who were there, and I just want to say thank you all so much for helping us to make that a really successful event. I think that we had the most people we've ever had this year, so very excited about the turnout. A reminder, if you attended Targeting Quality 2018, your free membership that comes along with that is valid starting today and up until the end of 2019, so the November 2019 meeting. And similarly, if you attended Targeting Quality last year in 2017, your membership from that is still valid up until next meeting. So other things we're looking to do this fall, we'd love to host another testing games event. We had one in the summer that was very successful. And so if your company might be interested in partnering with us on a testing games, reach out to someone from the board or email us at info@kwsqa.org if you're interested at all in that. On to today's meeting. So this is the second last meeting of the 2018 season since we've changed to running with the calendar year. An interesting thing about today's meeting is that we are actually live streaming this talk to another quality-focused group in the Lansing area. You may have heard of them. They're called the Lansing Area Software Testers, or LAST. So hello, LAST people. A reminder about RSVPing. So we typically set a deadline where we'd like everyone who plans to come to respond and let us know. This helps us order the right amount of food. So basically, if you RSVP after that date, then we haven't considered you in our order for sandwiches and stuff. So as much as possible, please help us out by trying to let us know by that date. So today, our speaker, we have Lauren here, pleased to bring you some local talent for this meeting. He's going to be talking to us a bit about some of the more complex and interesting parts of bug reporting, and I believe he's also going to be looking for some of your thoughts during the talk too. I know there's some pause for discussion portions, so I will turn it over to him, and thanks everyone for coming.
Thank you, Tina. And hello to our friends over in Lansing area. Thanks everyone for being with us today. So today's presentation is called Well Stated, Half Solved. I'm going to look at ways where we can get those more difficult software bugs, those ones that once you've knocked down the easy ones, you've got the difficult ones left. And we're going to look at ways to make sure those are well reported, managed, and debugged so you can get your products out on time. And by putting in complete and actionable bug reports up front, we can reduce the number of cycles for log gathering and move the bugs through their life cycles more quickly. And then we're also going to talk about opportunities for QA professionals to fix bugs themselves and to collaborate closely with developers. So the title is derived from a quotation from Charles Kettering, who said, "A problem well stated is half solved." And we're going to apply that to bug reporting, in that we want a bug report such that someone can pick it up and hopefully without too much more effort and data gathering can arrive at a fix relatively quickly. So a little bit about me. I've worked in the telecom industry since 2003. I've tested software and some hardware. I've led test teams. A lot of my work has been focused on verifying standards compliance. You may recognize some of the logos here. These are the standards that the products I've worked with have had to comply. Some are regulatory from governments, others are industry standards. So why do we want to talk about bug reporting? It's something we all do. It's not the most glamorous topic in our field, but it can be taken for granted or overlooked. And even the most experienced and senior testers among us can develop bad habits. We want to correct those. And in today's world of agile development, we want to go beyond just reporting defects. We want to look for opportunities to deep dive, become subject matter experts, and fix bugs as well. So for first section, I'm going to talk about some good defect reporting practices. And I'll share tips that have worked for me. This is not at all to be one size fits all. Different organizations have different practices, procedures, and templates for reporting bugs. What worked for me, we may have a different approach, and we'll have some discussion, and everything's open for consideration. Just quickly, a note on defect management software. So I'm not going to make this presentation specific to any particular brand of software, but I'll assume something modern that has the basic states and state transitions and the ability to mention people on a case, the ability to subscribe for updates to a case, things like that. It's pretty standard. So the first question and chance for discussion is, what do you like about your defect reporting systems? What don't you like? You have a preferred system? Anybody? Any opinions on bug tracking software? Something you'd like to change? Go ahead.
I think one of the challenges is that, up front, the state changes seem to be, okay, let's test this. And then the challenge of the software is that, okay, what about that exception?
Right.
So often the tools don't deal with exceptions well.
Yep, good. That's a good point. I prefer a sort of a lightweight and nimble bug reporting system over one that's gotten many layers of hierarchy and complexity. One system we worked with in the past allowed you to have multiple assignees at a given time. And that created a little ambiguity because no one was sure who the next action was on. So we scuttled that, and the system we run now, single assignee. So just a note on the bugs we're going to focus on today. You can have a fairly simple defect where the colors of the icons are incorrect. And for a defect like this, you can arrive at a fix relatively quickly and, importantly, without risk of breaking anything else. So we're not going to talk too much about these types of bugs. I want to talk more about the Rube Goldberg kind of bugs there, where you've got some convoluted contraption, and maybe you're trying to send and receive data, and you've got some sort of odd channel conditions with some noise in the way, and then you're finding you're dropping 1 out of 1,000 packets, and the spec doesn't allow you to drop that one packet. So how do you fix that? How do you improve the performance of your module's receiver to achieve the error rate? Another example of a complicated defect, this is something similar to what I've worked on. You can have a product with a specific customer configuration, and after it's been, it's a video processing engine, and after it's played out for about 2 days, the latency through the system spikes. It runs out of memory, and it fills the logs with a generic warning that does not at all point to the root cause. So these are the types of bugs we want to look at today. So let's take a bug report that's not actionable and kind of vague, and let's look at ways we can improve it. So we want to have some concrete steps to reproduce, right? Reproduce the bug. We want to talk about the environment. We want to include the details of the application. What version did we install? Made sure it installed correctly. And if you can apply the configuration file, if you can package that up, attach it to the bug, then the person who is going to reproduce it, they have all the config steps right away. They don't have to manually configure it. And then a tip that I find, if you can automate the steps to reproduce your bug, developers will appreciate that. We're all busy. We don't have a lot of time sometimes to sit and go through steps. If you can attach a little script to reproduce the bug, it'll be much appreciated. Again, we want to have a statement of what shall the software do versus what does the software do. A clear statement stating what's wrong with the problem. So here we note that we should be able to complete the actions without crashing, but that it took us in 3 different runs, 6, 8, and 10 executions of some actions to produce a crash. And we've gone and said what the error code is for the crash. And I always like to be as precise as possible and quantify things whenever there's things to be quantified. Another thing that we want to include in our bug report is supporting data, right? We have a good relationship with our development teams, but we don't always just want them to take our word for it. We want to gather the logs. We want to gather crash dumps, stack traces, anything that can help and produce a clearer picture of the bug and provide as much context as possible. I find that to be helpful. Another option is you can also have a collaboration session where you sit with the developer at your desk and you work through the system. You could provide the remote access details for a specific system that reproduces the bug and turn it over to the developer that way. Just be aware that your clean QA environment doesn't become a dev environment with all kinds of shortcuts and tools and things you don't know about. So you have to apply a little bit of care there, but often collaboration can help if it's a bug where the developer can sit with you and reproduce it. Supporting data is especially important if it's a bug that's come in from the field. Let's say you have a customer installation that's 12 time zones away. Your workday and their workday are offset, and every log gathering cycle can delay you by a day. So supporting data is a helpful thing to have there. Also, some analysis, some interpretation. If you are familiar with some of the software modules and there's a certain warning that catches your eye leading up to the crash, put a statement in your defect report noting that you have flagging these warning prints. Be careful with this in that you don't want to speculate and lead people down the wrong path. You want to avoid red herrings. But if you have some confidence about including some analysis of what's going on, it can help a lot with the context. So here's another example of providing some analysis. Let's say we have a process running on a machine, and we have a script that every so often samples the memory footprint of that process. Now we could hand off a list of comma-separated data points of the time and the amount of memory used, but that would be a little bit difficult to look at and scroll through text to see if there's a memory leak. More effective is to plot it. And in this case, we've got some, looks like some increase, but if we go and then apply a trend line, then it becomes clear that we have evidence of a memory leak here. So there's another quotation I find a helpful reminder to me to do the best I can and quantify data, quantify whenever I have the chance. Bug is in better shape when it's got some concrete data and numbers backing it up, if that's the scenario. Also, want to restate that if we're thorough up front, we gather our logs, especially in the case, again, of a remote bug, one that's difficult to reproduce, one that's in a customer site far away, we can reduce the number of data collection cycles. So practical example was one product I worked on. It wrote log files to about a dozen different places on the machine. And we would have bugs reported from the field. And there would always be some log that was missing. So we had a team member write a simple PowerShell script that grabbed all the logs, zipped them up, and then our folks in the field just sent us the zip bundle. And it cut down on the amount of times we had to ask for new logs. So. Another point I've found helpful is to retain a degree of ownership over a defect once you've entered it. It can be tempting to hit submit and wash your hands, but there are times when you may be asked to follow up with further information. There may be times where someone needs clarification. You may have to revise the bug. So keep an eye on the defect, especially if it's one of high severity or high priority. And when asked, take a couple seconds to pipe in those comments so that you can unblock another team member. So we've all experienced some disappointment, I'm sure, at one point when we've entered a bug and then someone's closed it on us right away and say, no, we won't fix this, or that's not reproducible. Yeah, it can be a little disappointing, but it's not the end of the world. My advice is use your due diligence when you put in the bug. Make sure repro it a few times if you can. But even if it gets closed, at least you have a record that you observed the behavior, you flagged it, you recorded it, and that way if a customer discovers it down the road and people come back to QA and say, hey, you missed this defect, what are you doing? You can say, hey, I put the bug in, they closed it down on me, I did my part. So that's just a little QA paranoia that, that I have. And then we've all had the case where we think we're doing the right thing, but we have a user error, a bug due to error on our own part because we maybe didn't understand a requirement or a step to operate the product. In this case, it's likely that someone else will run across the same problem. And it may be something endemic to the product itself. Perhaps there's something that's a little unintuitive about the way to use it. And you can argue that, okay, yeah, I made a mistake, this bug isn't legit, but if the product were improved in such a way, I wouldn't have hit the wrong key. In this case, it may be helpful if you have some wiki collaborative software, just to make a quick wiki page and say, hey, this is a potential pitfall. Share the knowledge with others And maybe it may even make it into your product's documentation, something like that. So, metrics for defects. And we little opportunity to have a discussion here. Some companies' managements may want to rank or grade testers based on how many defects did you enter a week, or how many defects did you enter over the life of a project, or how many of your defects were valid versus invalid. Has anyone ever experienced a situation where you've had some metric that you've had to meet and perhaps you didn't feel that was a fair representation of the efforts you put in? Has anyone had a chance where they've had to? Yes, please.
My dev manager thought he would set up a system where the developer who produced the fewest bugs would get a $50 gift card. The tester who found the most bugs would also get a $50 gift card every month. So I collaborated with my developer. 1 month, he's going to put in as many obvious bugs as he can. The next month, I let everything slide and he gets the gift card.
Way to game the system. Good job.
Mark,
Yes.
can we summarize that for the stream?
Oh, sure. So the observation was that there was a scenario set up where the management offered development a $50 gift card for having the fewest number of defects in their module, and then offered testers $50 gift card for finding the most defects. So the QA tester and the developer collaborated, and they said, 1 month, we're going to not find any defects in your code, and then the next month, you're going to put in a whole bunch of little defects that I'm going to find, and we're going to reap the rewards. Thank you for that story. That's a good one. Anyone else had an opportunity where they've seen that, hey, these metrics are, not an accurate representation of what we're doing here? Anyone else had an opportunity? No? Okay, we'll move on. Next section, we want to talk about defects throughout the life cycle. We're not going to talk about the details of states and transitions. We all know that stuff. But we're going to talk about some specific sort of defect archetypes that can get jammed, stuck at various points in the life cycle. Just a quick note on this. Some QA organizations I've worked in have also had a dual role where we've also sort of been gatekeepers for bugs that come in from the field or from support, and we've had some additional triage responsibilities. Has anyone else worked in a QA group where you've had this dual role? Yeah? Any comments, anything you want to share? No? Do you ever find that one side kind of crowds the other out? No, it's pretty well balanced. That's okay. So a tip is if your QA group has this triage role, if you can make a list of specific software modules or products versus the dev leads on them, build a rapport with those leads. It'll help you get the issues shuttled to the right people faster. So, the forgotten bug, the one that seems to get fossilized and kicked around for a while. This can tend to happen if you have a bug that's in the wrong state or assigned to the wrong person, and you may throw a comment in and say, hey, Joe, hey, Jane, what's the status on this bug? But then the bug's still sitting with you or someone else. The thing to do in this case, assign the bug to the person having the next action. And then when the project managers run their weekly reports, they'll get flagged as being with the right owner, and then they can shine the spotlight on them to get it moving. So, gotta get the bug moving. Another one is sort of the gigantic audience bug. So if you've had a bug that's been in the system for a while, and we're not quite sure which team owns it, more and more watchers get added, and then every time something changes, it kicks out a whole lot of spam. So in this case, I'll give you an example. If you're working on a product that, say, has like an OS and firmware component and an apps component, and the bug keeps getting kicked back and forth between the teams until finally we narrow it down. Okay, it's a problem in the OS and firmware. The apps team is absolved. You could probably remove a lot of the apps team watchers from the watch list, just so they're not getting spammed, and they'll appreciate it. They can resubscribe if they're really interested. Then there's the hot potato bug. And this bug is usually the one that's super high priority, critical severity. It's got all the executives watching it. It's gating some release that has to go out at the end of the quarter, and nobody wants to hold on to this one. It's got a lot of scrutiny. It can be also contributed by the fact that the description may be vague, or maybe missing key data. So sometimes due to the haste in passing this one around, we can miss something obvious. And what's worked for me in the past with this one is just to take half hour, 45 minutes, whatever, close your email client. If you have an office door, close that, put on your headphones, and just do a deep analysis through the logs to try and find out what really is the problem here, and then route it to the right person. And once you may see something quite obvious, and then that was missed, and then it may not be so bad after all. So just take the bug to yourself, tolerate a day of scrutiny, and then do the analysis and then get it moved on. We've also got the self-regenerating bug, the one that we can never seem to get rid of, that just keeps reforming and coming back. Sir? The situation here is where, so you've got a certain function of the software, function A is broken, and then it gets fixed and it comes to you for verification. And then while you're verifying that A, yes, is indeed fixed, B is broken. And then C and D and E, and it repeats ad nauseum. And what I find in the best case here is once you've verified A is fixed, close the bug, raise a new bug for problems B and C and D, and link them. And people will appreciate that because the developers don't want to read through a comment history that's a mile long, and having too many problems described in one bug gets confusing. So I find the way to deal with this one is just to close it, spin off others, and link them. All right, in our final section, I want to talk about going beyond reporting defects and verifying them. We want to look at doing deep dive analyses into different bugs and perhaps fixing some of them ourselves. So we've got the onion bug, and that's the one with layers. You have to peel back layer after layer to find what the true root cause is. And it can also make you want to cry. So this one usually requires a deep dive into multiple sets of logs, or you've got to attach a debugger, or you've got to get a dev build with a whole bunch of extra prints in it or something like this. And hopefully your logs can be lined up via timestamps if you're looking for a certain event that happened at a given time. One product I worked on, out of the 10 or so different log files, 9 of them logged in local time, but 1 logged in UTC time. So I was always looking how to add that 5 hours. Why is this one 5 hours ahead? We did put in a case to get that fixed so it would match the others, but just something to be wary of if you're correlating across multiple sets of logs. So here's an example of a bug that my team had worked on once. So we had a mobile device and a network simulator, and what the device was supposed to do, it was supposed to turn on, find the network, register. Then it was supposed to ask the network for an IP address. The network would assign an IP address. And those steps passed fine. And then once it got its IP address, it was just supposed to sit there and do nothing. But The test failed because the mobile transmitted something unexpectedly. And the network simulator logs didn't tell us a whole heck of a lot. They just said, something was transmitted, fail. Well, thanks, that's really helpful. So what we had to do, we had to go through the mobile device logs. We had to look at the modem logs to eliminate the lower layers in the protocol stack. If they had some sort of data to transmit or a timer expiry that initiated a transmission. We had to look at the applications side logs. We were running with some app running on the device that was trying to connect to a server out there somewhere. Was that what was causing the transmission? No. Then we had to look in the OS and finally get some Wireshark logs. And what we finally discovered was that in this case, we were getting an IP version 6 address, and there's a procedure with address auto configuration that actually it's expected that the IP stack in the mobile will make a request. So we came up with two solutions, a short-term fix and a long-term fix. The short-term fix was we had a OS guy who gave us a syntax for a packet filter, which we applied to the mobile before we ran the conformance test. And then those packets just got filtered out and they didn't hit the network interface. The long-term solution was we filed a change request with the standards body who produces the test cases and pointed out that the core design specs that these things are built on allow this transmission and that the tests had to be updated to accept it. So when the next round of conformance tests came out, the transmissions were accepted, and then we didn't have to use our packet filter anymore. So it took us a while to figure this one out. We had to work across 3 different teams, plus our standards representative and our test equipment suppliers to get this one fixed. But it was a good learning exercise. And then finally, as we're dealing with agile environments, now the demarcation between tester and developer isn't always as clear-cut as it was back in the waterfall days. We've got agile teams, and we've got test tasks and development tasks. And if we've got a cross-functional team, the next person can pick up the next task, whatever it is. And this can give testers a chance to get their feet wet with coding, bug fixing, and stuff like that. And it's a great learning opportunity. First thing is, talk to the development manager first. Express your interest to jump in and fix bugs. And I would hope that most of the time they would be grateful for the efforts, and they would say, "Yep, dive right in. We'll get you started." But have that discussion first, and get some guidance from an architect or someone who's very familiar with the product. Then you want to sync the product source code, and as you have time, just study it. Read through the files, ask some questions of your colleagues, learn how it works, build it on your machine. Just take those steps to get familiar with it. Then when you have a bug that fits in with the, fits in with the module that you've studied, make your attempt at a fix. Of course, use good practices for your coding. Make sure it builds and compiles without warnings or errors. Check it on your machine. And then, of course, very important, get a code review from someone who knows the product well. And then once you build it and check it in, the question is, can you verify your own fix as a QA person, or should it go to another member of your team? Any thoughts? Would it be a conflict of interest to verify your own bug fix? Anybody care? Yeah. Pass it off to someone else for a unbiased look at it. So I'll give an example of one chance when I had a chance to fix a bug. We had a product that involved an NTP client. NTP is Network Time Protocol, and a lot of computers use it to get time from a server so they can set the time accurately. We had a this product read from a simple configuration file off disk, and it talked to an NTP server. The NTP specification, the communication is very simple. It's a request. Okay, what time is it? Here's the time. And then the client does a little bit of math on the timestamps to remove the propagation delay, and then you get a nice accurate time. The spec gives a specific range of polling intervals. So what's the shortest amount of time that the client can go between requests, and what is the longest amount of time the client can go between requests. And the developer who had first implemented this product, he got reassigned to another very high priority product, and just wasn't available to maintain this one right now. So I said to the dev manager, you know, I've been working on this area for a while, testing it. I've become quite comfortable with it. I'd like to make an attempt at some bug fixes here. And they said, yeah, we'll get you set up. So the first problem I noticed was the polling interval was below the lower limit for the spec. I could see in Wireshark the spec said, thou shalt not send requests more frequently than 16 seconds, and it was sending them every 15 seconds. So I went into the code and I found that the interval was indeed wrong, and that it had been hard-coded using a literal value. So the first step I did was change it from a literal to a variable with a meaningful name. And then once I proved that works, I added support for variable polling intervals. So I plumbed it in through the config file and put some bounds checking on it, that it would reject anything below or above the spec limits. And then I tested that on my machine with different number of values. And then finally, the last step for it was the NTP spec allows the server to tell clients in cases where it's overloaded. It can tell them, hey, back off, reduce the frequency that you are polling. So if I send you a packet with a specific payload, you have to double your polling interval. So I implemented that back off mechanism according to the spec, and got it all reviewed, and it checked in, and now we have a NTP client that is spec compliant. So it was a fun learning exercise, and it's a great chance to get to know the product better and to help out with fixing some defects. So is there anyone in the audience who has interest in fixing bugs as well as reporting and verifying them? Yeah, that's great. Has anyone had chances to check in fixes to bugs yet? Not yet? Yeah. Anyone have a story about a bug fix that they did and they were proud of? Yeah.
Just fixing a CSV implementation error in the backend web service, and customers didn't really get it back to their feed.
Yep. Right on. Good stuff. So, oh yeah, go ahead. Oh yeah, so Kyle noted that he had fixed an error in the web service that customers had complained about, and that his fix had been effective and was well received. So, good stuff. So that takes us to the conclusion. As SQA professionals, we can contribute to a product success by effectively reporting and managing defects. We can become subject matter experts via deep dives into logs and specifications. And when the circumstances allow, we can go and fix bugs ourselves. So thank you, and we'll have a time for Q&A if there's any questions. Yeah?
I can start. So I totally agree with all the stuff you were saying here at the beginning about making sure you have good information and you've looked at logs, and maybe I love the idea of graphing stuff like memory usage over time and stuff like that. But I can think of cases where I'm seeing something that I know isn't right, but I honestly haven't been able to find any good way to reproduce it or anything in the logs that looks relevant, or just like very much at all. And so do you have recommendations about what to do? Like, do you typically hold off on logging it until you know something's useful, or have you had success with just kind of logging it anyways and being like, I seriously don't know what's up with this, and then
Great question.
seeing if someone else can take it from there?
Okay, great. So just for the folks on the stream, Tina's question was with regards to collecting data. Sometimes you'll get a case where the logs show nothing obvious, and it's a very intermittent issue. Do you hold off on reporting it until you have data, or do you report it? What do you do? And that's a great question. This does happen to me as well. What I will sometimes do is I'll try and go through a few times, see if I can get it to happen more than once. If there are no logs, sometimes all I have is a screenshot of a particular problem, which is better than nothing. I will sometimes log the bug and put a note on it. I'm keeping this with myself until I can get a little bit more data and then send it through the triage process. So I've done that in some circumstances before. Yeah. Any other questions? Any other feedback? Stories? Anything else? Yeah.
Are there times where, thinking about it for my own purposes, like maybe something is so obvious, so prevalent that it's almost unnecessary to over-document
Yep.
the environment? Like how do we draw the line so that we define good standards and don't just like...
Yeah, good question. So the question was if there's a bug that's so obvious and easy to reproduce, perhaps trivial to fix, it may be too much effort to go through and log a really complete bug. And I would say in that case, if a developer is handy to fix it and can fix it and spin a build, then you would not have to go through a process of putting a big full and complete bug report in. Different organizations can have different things. Some would be more stringent. Some would say, yeah, just fix it. Start again on the next build. Yes? Yeah. Yep, good point. So just for the folks on the stream, this was a follow-up to Tina's question. And if they're in the case where you see a behavior you know is wrong, but there's no logs, go through your defect tracking system and look for similar reports. And then if you can, correlate that with the behavior you're seeing. So yeah, thank you. That's a good point. Anything else? No. Okay, well, thank you very much for your time, and thank you to the folks in Lansing for tuning in. Appreciate it. Have a great day.